So today what we're dealing with is a thing called annuities. I want you to think of annuities as very similar to compound interest, but it's compound interest on each individual payment that we make. Now, when we talk about annuities, we think of this thing we call the residual. And we're going to talk about this in the examples below. Basically, you deposit $20 into your paycheck every 3 months for 3 years. Notice, we always talk about a certain deposit and a number of years. Now, this value here, the 20, we call the residual. R, which is also known as the residual, or the payment. But it could also be a withdrawal. And we will talk about that in the next lesson. Now, let's take a look at the next problem. When we look at this, we have parents are depositing $500 every 6 months for 4 years. Well, basically, the R value, the residual, is $500. And the time it takes to pay, the time it takes to pay this is 4 years. So now our next one is we pay a mortgage of $985 every month for 20 years. So our R value is $985, and notice our R value is a capital R because it's very important. Little r or little I represents some form of rate, right? Or interest rate, okay? Now, basically what we're going to do is we're going to consider the following equation. So basically, if you think about it, I'm actually going to explain how this future value thing works. You already understand what compound interest is. It just starts as a certain amount and then starts building interest. So if we were saving money and you kept putting money into an account, each of those individual payments that you had put in would act like its own compound interest. And over the years, the money that would have stayed in the bank the longest would have had the most amount of compounding. And then the next one would have just a little less more compounding, and the next one would have a little less more. And then by the time you get to the end of your final payment, the last payment of your account has no interest tacked onto it, but it has all those other ones that have been totaled up. And when we do the calculation for something like that, we end up with something that looks like this, where FV is exactly what we expect it to be. The FV stands for our future value. Just like before. So, how much interest have we made on all the money in the deposits that we've made? But the R value is our residual. Okay? Just like before. So this part is the payment or deposit. Deposit is the payment or deposit, right? And we'll have to take a look at what these other parts are. So the N value is exactly like how we calculated before. The N value is the years times the compounding number. And this I value that exists here, and notice my I value is in brackets on the bottom. Please make sure you're calculating it just like you would have calculated your interest when you were dealing with compound interest. And that was always whatever the rate was divided by the compound number. And basically R is just the amount of the regular deposit for this problem that we're working on today. Now you need to understand the frequency of deposits that we have must match the compounding frequency of the interest. So this number here and this number here must be the same. Now let's move on to our next problem. Here we go. The next problems require us to calculate future value, the amount of money that we have at the end of our annuities. All right. Now, the first problem says we have $30 at the end of each month for 3 years, compounded monthly. In order to calculate this, what we're going to do is we're going to basically just set up our future value problem. So we'll just start by writing our equation. Always start by writing the equation you're looking at. And I'm going to write this as double bracket 1 plus I to the n minus 1. You don't have to use the square brackets that we normally used before. And then we're going to divide by I. Now, we're going to substitute. Notice the 30 is going to be our R value. When we're talking about compounding monthly, we're actually talking about 12 months that happen in a year. And this part here represents the rate we're using. So now let's just quickly do our substitution. So we have our value is 30, so we're going to put 30 in. Put our double bracket, and we have 1 plus 0.05 divided by 12 raised to the, 36. Now, how did I get 36? 36 came about by actually taking 3 years and timesing that by 12. So remember, our compounding number is 12, right? And the number of years that we have here is 3. So 3 years times 12. And that's what we get right here. And we continue with the rest of our equation. Minus 1, all divided by, notice the bracket I'm always putting around my fraction. If I don't put that bracket around my fraction, we're going to have some issues. Remember that 5% is 0.05. If you're not sure, do the calculation on this side. 5 divided by 100 equals 0.05. And then use that 0.05 in our equations here and here. Now, all we have to do now is punch it in exactly as you see. The top half of the so what we're going to do is we're going to start by multiplying 30, then we're going to type in bracket 1 plus 0.05, and this part here means divide by 12. So I'm actually going to write that out as how you would write that on your calculator. You'd write 30 bracket 1 plus 0.05 divided by 12 raised to the 36, and bracket raised to the 36 minus 1, bracket, and then you divide by bracket 0.05 divided by 12, end bracket. Now if you do this correctly, you'll get your calculation in one step. In this case, we end up with $1,162.60. What I'd like you to do is I'd like you to try doing that calculation on your own, and just talk to your teacher. You might have some issues with your calculator when you're punching it in. Just take your time and work through it. Pause the video now, try that. Carrying on with our calculations, we have our next problem. $50 deposited each month for 18 years, averaging 7.2, compounded monthly. So here's what we're going to do. We're going to follow the same pattern that we did before. We write out our equation. Future value is equal to R, bracket 1 plus I to the n minus 1 divided by I. So now our future value, we have to figure out all these things. So now I'm actually going to look up here. So this has got to be my R value. This is my rate, which is 7.2 divided by 100, which is equal to 0.072. I use that in my calculations. And then I have 18 years compound. Oh, and the compounding number is monthly, so that's 12. So let's substitute all that in there. So R is 50. So that's where we get this. R is 50. Next, we'll substitute the rest. 1 plus 0.072 divided by 12 raised to the, well, 18 times, well, our compounding number is, oh my gosh, 12, which ends up being 216 is what's going into my exponent. Minus 1, and then we divide by 0.072 divided by 12. So the next thing we have to do is just punch in our calculator and see what we get. So remember, on your calculator, you're going to type in 50, bracket, bracket, 1 plus 0.72 divided by 12, end bracket, raised to the 216, subtract 1, end bracket. And then divided by, bracket, 0.72 divided by 12, end bracket, and then hit enter. Now, by doing so, you're going to get the following answer. And we get the following number. $22,000, $22,004.36. So, all of the rules that we dealt with before all come out to be the same. So remember, if you ever have to calculate interest, you take the future value and subtract the present value, and we can do that. It's not that difficult. We'll focus on that in the next unit, but until then, what I want you to do is I want you to work on these questions here. 205, 11, 18, 19, 20, and 22. The questions are loaded up on the website. Good luck, kids.